In this lesson, we are going to be applying what we've been doing with linear inequalities and shading and making the tables to an actual word problem. So I'll let you read the problem. You can pause this and then come back to it when you're done. But basically it's telling us that we need to schedule some office visits for the veterinarian. So Bryn has her reception schedule her appointments. It makes sense why you'd want to do this because if you own your own business, you're not going to want to be at work and not have people coming in and making you money. If I go to work for 8 hours and I'm a vet, I want to make sure that during those 8 hours I'm actually seeing animals so my time isn't being wasted. You have bills to pay as a small business owner. You're going to have to pay your mortgage for your vet clinic. You're going to have to pay your workers, your receptionist, everyone. You want to make sure while you're at work you're busy because that's what brings in money. If you're sitting at work with nothing to do, you're not making any money. So we're going to help her schedule appointments so she can fit them in the schedule. The first thing to do is to define the variables and say what they're talking about. So the two things that I see that they're talking about are surgeries and office visits. So those are our two variables we're going to define. I called my office visits V because I don't like to use an O. So number of office visits. Some of you might, if you get really confused by X and Y and you want to use X and Y, if you look at the graph I gave you, I actually labeled the Y-axis your office visits, so you might want to call your office visits Y. That might help you as far as graphing and knowing which way to put the, or which variable to solve for later. And then when I did my other one, surgeries, I called that an S. So S is my number of surgeries she's doing per day. And again, you could call that X then, because you'll notice on your graph that the S is labeled as the X-axis. Writing a system of inequalities now. There are some constraints given to us in this problem. The first one is one they don't actually tell us, but it's one we're expected to know. And that's the fact that you can't have negative office visits or negative surgeries scheduled in a day. So when I look at this, I can't have a negative office visit or a negative surgery. So I'm going to say that my V must be greater than or equal to 0, and so must my S. And that's going to be true for a lot of the problems we do. Our V and our S, or whatever we're talking about, is going to have to be greater than or equal to 0. I can have 0 office visits, but I can't have negative office visits. Next, then I'm going to look at what they tell me for the constraints. So as I'm reading the problem, this first line is just information, right? They're telling me 40 minutes is a surgery, so each surgery is 40 minutes. 20 minutes for an office visit. What other data do they give me? She can't do more than 6 surgeries in a day. That seems important, right? And the office is only open for appointments 7 hours a day. Now down in this part, this money part here, where it says how much it costs to go, we're actually not going to deal with that in the constraints. When you're scheduling appointments for animals to come see you, you're not going to turn away someone who's sick because it's not a surgery and it doesn't make you as much money. That's not a good business practice, nor is it morally correct. So think about if your doctor said all of a sudden, well, you only have strep throat, you probably won't die from that, so I'm not going to see you. You can just be miserable for quite a while, and then when you're near death, I'll see you because I'll be able to charge you more money. That's not how it works. And so you're going to have to schedule office visits and surgeries no matter what. So the money part isn't going to come into play until later. So I'm going to ignore that for now. There are times money matters. This just is a problem where it doesn't affect it. So now when I look at my constraints, one of the things it says is Bryn can't do more than 6 surgeries in a day. That's just talking about the surgeries. So I'm going to use my variable for surgeries. She can't do more than 6 in a day. So that means she can't do more would be less than or equal to 6. She can do 6, so I could say S equals 6, but she doesn't have to do 6. If she has 1 surgery or 2 surgeries a day, she's not going to turn those away. So I'm saying S is less than or equal to 6. So that takes care of this part right here. So now in my mess I've made here, I still have this 40 minutes for a surgery, 20 minutes for an office visit. If I wanted to write those in expression, I'd say it's 40 minutes per surgery and 20 minutes per office visit. I was going to do an O. Let's make that a V. 20 minutes per office visit. So it's important that they tell me I only have 7 hours available to schedule appointments, which makes sense because she'd probably have some appointments that run long and some charting that she'd have to do as a doctor. So she's going to schedule appointments for 7 hours of her workday. So now as I write that, I'm going to say her surgeries plus her office visits has to equal the 7 hours a day, right? And since I'm doing surgeries and office visits in minutes, That's why they gave me that 420 minutes. So it's equal to 420 minutes. I would think I put equal here, except what if she doesn't have appointments scheduled for the whole 7 hours? What if she only gets 4 hours filled? Is she going to say, that's not worth it, I'm just not going to come in? No, she's still going to come in and work. So I'm going to make that less than or equal to 420. And now I've dealt with all the constraints that are in this problem. There are other factors you'd have to think about when you're scheduling. We're doing it much more simple than you would normally, but you'd also have to think about leaving some openings for some emergency appointments where people come in and say, I need to come see the doctor right now. My horse just got kicked, my little calf just got kicked by a horse or whatever. So now when I look here, I'm going to graph these inequalities. I'm going to show you, don't graph this right now, just listen to me for a minute because I want to talk to you about these two so your graph doesn't get too hard. Right here, these greater than or equal to 0. That's really these two lines right here. And if it's greater than or equal to 0, that's all of this in quadrant 1. I can't have negative answers, so these 3 quadrants are out right from the start. So a lot of times I choose to maybe graph these lines, but I don't choose to shade them. I just know in my head my answer has to be in the first quadrant. Because if I did this right now, my graph is pretty messy. And to start to graph another line on top of that and try to find shadings and put more shadings, then grab another line on there, it gets really hard to read. So I would suggest knowing that your graph has to be in the first quadrant. And you have to technically graph these because they're part of your equation. So the y, or the v is greater than or equal to 0 would be a horizontal line at 0. So I'm going to graph that one. And my s is greater than or equal to 0 is a vertical line at 0. So I'm going to graph that one also. I'm just choosing to just remember that the shading is in that first quadrant. It's right here where there's only positive values. And I won't actually shade that. You can. I'm not going to say you can't, but I think it'll help keep the mess of the graph. It'll be easier to read. So now as I go to graph the other two inequalities, s is less than or equal to 6. I know that s is my x-axis, so that's a vertical line at 6. So I'm going to go to 6 here and draw a vertical line up and down. I have that point right there where I started at 6. And that one says x is less than or equal to 6. So I'm going to shade x is less than or equal to 6. And that'd be this way. Okay. My second line then, I'm not really ready to graph that yet because I want to get y by itself. Remember our v is our y, so I'm going to come over here and do that. I have 40s plus 20v is less than or equal to 420. So I'm going to minus 40s from both sides. I would then have 20v is less than or equal to negative 40s plus 420. Divide everything by 20. And I have v is less than or equal to negative 2s plus 21. So there's where I can graph. I'm going to start at 21, which is kind of hard to do. It's right here. And it's a pain when your intervals aren't right on, but that's going to happen sometimes. So you have to be able to graph around that. The nice thing about this, though, is my graph all goes by 4s. My intervals on my x and y axis are by 4s. So I don't have to actually go, okay, 2 down, 1 to the right, and try to figure this out here. I can go exactly 2 down and 1 to the right. So I'm going to go down 2 right here and go 1 to the right. So there's my dot. Down 2, 1 to the right. I'm really moving down 8, right 4, but it works out the same, and it's easier for me to do that when I have smaller intervals. So there's that line. You will please use a straight edge. And then this line says less than also. So as I go to graph that, the less than part would be right here. So I'm looking right now for only answers that have green and blue, but they have to be in quadrant 1. They have to be in the middle of those red lines. And so some people might think like this area would count. That doesn't. That's outside of my quadrant 1. So my actual area where I have my graph, or my common shading right now, is just a little trapezoid looking thing here. Right there. See that? Some people might think that it would be this area right here, but there's no green. So it's not the triangle, it's just that little trapezoid. So now I have to find the vertices. I can name this one right here. I know that one. I started there. That's 0, 21. And I can name this one. That's 0, 0. And I can name this one because I made that point at 6, 0. This one right here, oof, I could guess it. I have no idea what it is though. So that's going to happen sometimes where your vertices cross at fractions and you don't know exactly where they are. So what you do is you look at the two lines involved in that. The two lines that are involved in that is my blue line, so right here, and my line in green, right here. And then I treat them as equations and I solve for the intersection point. So when we learned substitution and elimination, it was for this. I'm going to take my s equals 6 and my v equals negative 2s plus 21, and I'm going to substitute 6 in for s. I know that point then, that order pair is going to be 6 something because s is 6. So when I substitute here, I'd have negative 2 times 6 plus 21. Negative 12 plus 21 would be 9. So v is 9. So my ordered pair is going to be 6, 9. That won't happen to you a lot, but I wanted you to be prepared for when it does. So I'm going to go ahead and just put those in my table. So I have 0, 0, 0, 21, 6, 0, and 6, 9. So those are my 4 vertices of my enclosed area. Now, what's missing is last time we made a table, we were given this function. The function to be maximized or minimized. Would you think that when you're making or when you're working with a business, you want to make money, the most money you can, or the least money you can? Well, we want to make the most we can, right? I'm not going to go to work and not make a lot of money, hopefully. So you want to find your function to be maximized. We do that with the money now. They told us up and above in the problem that an office visit is $55 and a surgery is $125. So now you're going to see, okay, how can I schedule appointments to make the most money? If I had an ideal day, what would it look like? So I'm going to say that my function for S and V, and the reason I put it like this, sometimes you wonder why this is in your Excel math also, I'm defining my X and Y. My S is my X and my V is my Y. So the function of S and V equals, and then I'm going to say how much each of these things are going to cost me. So for every surgery I'd make $125, and for every office visit I'd make $55. So there's your function to be maximized, and you can just put in the expression down here if you like, so you know what to substitute. So as I go through, I take 125 times 0 plus 55 times 0. So if I don't schedule, one of my borders was 0, 0. If I don't schedule any office visits or any surgeries, I make $0 that day. Then I have 125 times 0. This is no surgeries, plus 55 times 21. So when I get that, I get $11.55. So if I do only office visits for the day, I make almost $1,200. 6 surgeries and no office visits, that's another one of the borders, I make $750. So let's say I want to work like a half day. Maybe that's an option there. And then if I do 6 surgeries, oops, why did I put 5s here? Let's make those 5s, you guys. 125 should be there, not 6. If I do 6 surgeries and 9 office visits, so I fill my day, I can make $1,245. So now, the maximum money in this list is right here, isn't it? Ideally, if they were asking us as a math person to figure this out for them, we would say in our answer, the maximum income for the day is $1,245 if Bryn schedules 6 surgeries and 9 office visits. There's my answer. I have just found out how they should schedule their appointments to make the most money they can. Just as a side note, this might seem like a lot of money for a business to take in a day, but you have to remember Bryn's not bringing home the $1,245. Part of that's going to pay her mortgage. Part of that's going to pay the insurance for her employees. Part of that's going to pay her employees. Part of that's going to still pay off the student loan she has from vet school. So there's a lot of bills that go into that. That seems like a lot of money to bring home in a day. Most of us would be really excited if we worked 8 hours and made that much money. But that's what business is bringing that in. So taxes go into that. There's a lot that goes into that. So that doesn't mean she's breaking in the dough right there either. There's a lot of bills she has to pay going out. I want you to try number 2 and see what you can come up with, and then I want you to start to play it and listen to it. So try it, get as far as you can, play a little, and keep going. So in number 2, hopefully you've read the problem. I defined my M as my number of mowing jobs, and my P as my number of pruning jobs. Just like in the last one, I can't have negative mowing jobs and I can't have negative pruning jobs. So again, my answer is going to lie in the first quadrant. So as I'm looking for my information, I want to keep, a good clue is to keep hours with hours. So if it's 1 hour for mowing and 2 hours for pruning, we keep hours with hours. The crew is set up for a maximum of 9 hours. See how that's kind of like our vet problem? So I would say 1 hour of mowing, so 1 hour times the number of mowing jobs, plus 3 hours times the number of pruning jobs, is set up for a maximum of 9 hours, meaning they can't work more than 9 hours. They can equal 9, but they can't work more, so it's going to be less than or equal to 9. The only other restriction they give in this problem is that the crew is scheduled for no more than 2 pruning jobs in a day. So this only deals with pruning, so I would say P has to be less than or equal to 2. The rest of the numbers they give me are money, and I'm again not going to take jobs based on how much they're worth. If I'm doing a business, I want to take all my jobs, right? I want to build my client base. So I'm going to take all those jobs and try to fill it up. So I'm not going to use the money till the end. As we go through here, you will see that I've already labeled your axis to say pruning here. So your P is your Y, and your X is your mowing. And you could really pick either one, it doesn't matter. I just like you guys to all be the same, so when I'm grading it I can tell whose is whose. So I will normally label your axis for you like that. Again, I'm going to have these 2 lines that are greater than or equal to 0. So those are still going to be there, and I'm going to remember that my shading has to be in quadrant 1, even though I didn't shade it. I would probably graph my P is less than or equal to 2 first, because that seems like an easy one to go with. The P is my Y, so that's really saying Y is less than or equal to 2, so that means I have a horizontal line right here. And if Y is less than or equal to 2, I would shade below. So that's going to be all down here. Whoops, got a little out of the lines. Ignore that spot right there. Bad. My next one then, I'm going to go to my equation on top, and I want to solve for P. So I have 1m plus 3p is less than or equal to 9. So I'm going to get P by itself, minus m from both sides. So 3p is less than or equal to negative m plus p. Divide by 3. So p is less than or equal to negative 1/3 m plus 3. So I start this graph at 3, and I go down 1 right 3, or up 1 left 3. Solid line. And it's less than, so I'm going to shade where x is going less than, which would be down here. So my answer now, I'm looking for a common shaded area where the green and blue are still in quadrant 1. So it looks to me like it's right here, quadrant 1, right? And all the way out there. There we go, another little trapezoid looking thing. There we go. So now I'm going to name these vertices. I can name this one for sure. That's 0, 2, right? And right here, that's 0, 0. This one I think I can name. That's 3, 2. Here's the one I'm not sure about where these cross. Let me see if I can find it. This was down 1, right 3. So it'll be right here. Down 1, right 3. I bet they cross at that spot if I had a straight line. That looks better, doesn't it? So I think they're going to actually cross at 9, 0. But let's double check that because I'm maybe not sure. My graph, I didn't do a very good job making straight lines. So I'm going to have to plug that in. I would use the two equations involved, which are the red line and the green line. So I'm going to use p equals 0 and m plus 3p equals 9. So I know it's going to be 0 something, or something 0. If I plug in a 0 for p here, I get m plus 0 equals 9. So it is 9, 0. I was right with my guess. So there's my other ordered pair. So now I'm going to plot those vertices into my table here. So 0, 0, 0, 2, 3, 2, and 9, 0. My function to be maximized, again, I'm going to use the money. So my ordered pair, my variables are m and p, mowing and pruning. For a mowing job, I make $40, so it'll be 40m, plus I get $120 for pruning. So that's what I'm going to put in right here. So again, if I do 0 jobs, I make $0. 0 mowing jobs, but 2 pruning jobs, because that's one of my boundaries, I'd make $240. 3 mowing and 2 pruning, I make $360. 9 mowing and no pruning, I make $360. So we actually, if we look here, we have 2 maximum values. So I have a choice when I schedule my crews. I can either schedule them for 3 mowing and 2 pruning or 9 mowing and no pruning. So I would say for my answer, Ethan makes the most money per day when he schedules 3 mowing and 2 pruning jobs, or 9 mowing and 0 pruning jobs. He makes $360 for both. It's really important that you answer these as sentences that people who aren't doing the math can understand. If you would be hired to do math for a company, you can't do math speak when you give them an answer. You need to give them an answer that they could make sense of. We will do more of these in class tomorrow, so if you're a little bit confused, hopefully we'll clear that up tomorrow in class.